Welcome to this Digital Masterclass presented by Food and Biocluster Denmark and Danish Food Innovation. Food and Biocluster Denmark is the new supercluster working to maximize and drive innovation for the food and bioresource industry in Denmark. My name is Helle Vedel Friis and I will be your host today. In this Digital Masterclass, we are focusing on sustainable packaging. What materials is out there for you to choose, and how do you actually look at packaging in a sustainability perspective? We are getting insights from a new report conducted by the Technological University of Denmark. DTU, they work to develop and create value through science and engineering to benefit the society and to help reach the UN Sustainable Development Goals. And I'm very pleased to have Anna and Gitte from DTU with me today as today's experts. And for those of you watching, please send us in your questions and thoughts by filling in the form below the video stream. And also, please let us know you are here by filling out the form to the right. This way we can continue to create these activities for you, and it's also through the form to the right that you will receive today's presentation and the report we are talking about. And first, Gitte, could you please introduce yourself?
Yes, hello, my name is Gitte Alsing and I'm working as Senior Advisor at DTU National Food Institute. I've been working for more than 20 years with food safety, chemical food safety in relation to food packaging materials.
Thank you. And Anna, could you introduce yourself and maybe to start with the basic, why is packaging actually needed?
Yeah, sure. So, hello, my name is Anna. I'm senior researcher at DTU. I've been working for many years with materials, particularly the natural biopolymers. And I came here with Gitte to give a bit of perspectives about sustainable food packaging. So, and main question, why do we need packaging? So, basically, packaging and what is packaging is a way to ensure that food is preserved until it gets consumed. And we need it, there's many reasons why we need it besides preserving the food until it gets to the consumer. So also it can extend the shelf life and can facilitate the transport, as there's many foods that cannot really handle stress or during transportation, or also in the shelves of supermarkets or in our homes. So it's also a way to transport, but also it can be very informative, as most of the packaging systems, they provide information like the composition of the food, the production, the expiring date, etc., which are also very important to the consumer. Besides the fact that having a nicer design packaging can also improve the sales of the food. So this is also very important to highlight why we need the packaging. Yeah. So as main considerations, what we need to consider to select a food packaging material, we need to think first, which food do we want to preserve? Different foods have different physicochemical properties and different needs, and it's important that we really know it before deciding which packaging material we should address. Besides the food by itself, it's important to know the packaging material properties also. And here the main properties we consider when we think about packaging, it's about the barrier properties, and barrier is nothing else than permeability to external agents that can be water, moisture, oxygen, even temperature, light, and so on. Those what we call the barrier properties of the packaging material to preserve the food. But of course, it's important that the material also can withstand or handle mechanical stress. So mechanical properties should be suitable to protect also the food. So first, if we talk about the food properties and the material properties, also is important when we place them together to see if they change. And this is a very important aspect, because sometimes we can have a packaging material that might suit the properties of the food, but when it is placed in contact with the food, those properties might change and maybe the performance is not so good. So those are the three main points we need to consider in food packaging. So, and the requirements are So we talk about the functionality of the packaging, that is about matching the needs of the given food to preserve it. But also there's another important aspect that is about chemical food safety. And this comes particularly during the production of the packaging, that some particles can be developed and can contaminate the food and make it potentially harmful for the consumer. So it's a very important aspect. My colleague Git might say something later about it. But also when we think about what we need from the packaging material, we need to consider the environment impact. So we want it to be lower as possible, but you'll hear later in the presentation on the webinar more about this.
And can you say something about the landscape today? What materials are used for food products out there?
So there's a huge variety of materials using food packaging, as you can see here on this slide. And we have a lot of packaging made of paperboard. That is one of the main components. We have metals, we have glass, but most of the packaging materials used in food area are made of plastics, which include rigid and flexible plastics. So those are the main category of food packaging materials. So, and why is that? Why is the packaging materials the ones more appreciated or more used in the food sector? So the reason is mostly plastics are light, they have lightweight, and they are known to have suitable barrier properties to protect very diverse types of foods. This is also very important. They are also flexible and very suitable mechanical properties. Plastics can also be transparent, which is convenient for many applications, and can nowadays most of the plastics can be produced without a large cost or investment to produce it. Besides the fact that if we live in Europe, most of the plastics used in food, they are regulated to be safe. But of course, those properties might change depending on the type of material. Composition is very important. This is not really black and white. We should consider all the time the type of the material we are using. So here you can see I have an overview about the common plastics used in packaging, and there's different categories. There's the petroleum or fossil types of plastics. There's bio-based, but also there's these non-biodegradable or degradable plastics, as you can see here. So there's really different, or can be compostable, and yeah.
And just maybe to clarify some of these terms, what is the difference between bio-based, biodegradable, and compostable materials?
Yeah, so because the plastic is called bio-based doesn't mean necessarily that it is degradable. And what is degradable or biodegradable? So biodegradable means that it is degraded into by microorganisms or enzymes into small into monomers, for instance, or smaller pieces of the polymer, or leading finally into water and CO2. But this is biodegradable, and then also compostable means that can be degraded under specific conditions in the environment. Yeah.
Okay, great.
So in the report we delivered, so we decided to categorize the materials into three main categories that are the petroleum-based, bio-based, and then we have a different section that is not necessarily made. In the first section are about polymers, and the later section is about existing materials or articles in the nature. So starting for petroleum-based plastic materials, this is the most common used materials so far that we have in the market, and you can see here several examples of petroleum-based materials that you use in your day-to-day life, like polyethylene, polypropylene, polystyrene, and PET that you use to build bottles, plastic bottles for water, and also other types of beverage, but also to use it as food containers. So you might have seen this type of products everywhere. But why is that? So why are these petroleum-based materials the common use type of materials? And the reason is that they really can afford good barrier properties, as we can see here, and good mechanical properties. And if we look, for instance, the example of PET that is commonly used in the bottles, you can see that it's good barrier properties to almost everything that is relevant, like gas, like water. vapor, odors, and flavors, etc., etc. But of course, this is an example. There's others that they don't have so good barrier properties. And
Okay.
yeah.
And I will just let those of you watching that I get some know that I get some information from you that you cannot find this masterclass on the drop-down menu in the form to the right to receive today's report. And I understand you would love to receive the report. What you do is you just update the website, and then it should be there in the drop-down menu that you can choose this masterclass, and then you'll get today's report from Anna and Gitte. That was just a little service info for you. But for these materials we're looking at here, Anna, many of these polymers you have shared on your list, you also see that they have low barrier properties. And how can this be improved?
Yeah, that is correct. There's some of them that they don't have so high barrier properties, and there's different ways to improve it by applying multi-layer barriers. That means that you create different layers of different materials with other properties that are convenient for the food you want to protect. So this is a way. Other ways is to create this, what is called modified packaging, atmosphere packaging, called MAP. It's very commonly used in the food industry, that you just regulate the gases in contact with food in order to extend the shelf life. But also there's other types of combinations like aseptic packaging or addition of oxygen scavengers that are basically absorbers, because many foods might oxidize when in presence of oxygen. So you can apply all of these type of technologies to improve the material properties. Yeah,
great.
Yeah, so this is petroleum-based materials, and although they are very functional and they are very used because of their good or suitable properties, there's some inconvenience when it comes to environment impact of these type of materials. And one of them is about the use of fossil or petroleum-based resources. They are not renewable, so they might be limited at some point in life. In addition, also when producing this type of polymers, there's a production of greenhouse gases, in particularly carbon dioxide and methane during the production. And the other main issue related to the use of this type of polymers is that there's no really good solutions to what to do to them after using them in our households, and most of them tend to be just wasted in the environment and stay there because they don't degrade really fast, or they don't degrade at all, or take many millions of years to degrade. So, and there's also some aspects related with the chemical safety using some plastic materials, but altogether, this is why food industry have been looking in different type of materials, and now comes to the equation what is called the bio-based materials. And here we define, or we subcategorize two types of bio-based materials. The first, that includes polymer synthesized from bio-derived monomers by fermentation of carbohydrate rich feedstock. So basically, industry can produce specific monomers, and after produce polymers with the similar properties and functionality that common to the petroleum-based materials, like bio-PET, bio-PP, bio-PE. So by using this type of bio-type of materials, let's say, we are already decreasing the emission of greenhouse gases, which is a convenient plus when we talk about environment impact. But of course, there's other type of polymers within this category of bio-based polymers, and those are the two main examples, like polylactic acid or PHAs. And those polymers are very interesting because, again, they are produced from biomonomers, but also they can be used in many different applications in food. Although they come with some drawbacks, they are not really, they cannot be applied in a broad range of foods for the simple reason that they don't have really good mechanical, but also they fail a bit in some barrier properties. But on the other hand, they are degradable, particularly PLA. Okay. Or compostable, yeah.
But if we look at these bio-based plastics that you just shared, and if it seems like they have some of the same properties as the petroleum-based ones, why don't we see it as much out in the market?
Actually, it's a very good question. So it's true they have a similar functionality. However, it comes that still for the moment they still come with a higher cost compared to the petroleum-based. So they are more expensive than petroleum-based. However, because there's some industries looking to produce them from waste or byproducts from other industries, there's a perspective that the price will tend to lower. So might be a chance that the consumption of these products in the market will increase in the near future. Yeah.
Okay. And can you give some examples of food products where these materials could be relevant to use?
Similar like the ones we just saw the examples, like bottles, or here you can see here bottles, or the food containers, or really plastic bags, or there's many different applications for this type of materials. Yeah.
Thank you.
Yeah, and then comes the other category of the bio-based materials that is called natural biopolymers. And as you can see here, we can find them almost everywhere in the globe. So they can be extracted from algae, from plants, produced by microorganisms, or from animals. And here there's some examples. And basically, natural biopolymers are already existing polymers in the nature. So this is, we don't need to produce them. They already exist the way they are. So we need to extract them, basically. And we categorize by natural biopolymers mostly into proteins and polysaccharides. Here you can see some examples of the most common used polysaccharides, like starch. Particular thermoplastic starch is widely used on the packaging sector, but also cellulose to make films and plastics. However, I would like to add that cellulose is the main component not only for plastics but also to make paper boards. But also can be used in the plastics. Yeah, but also proteins have been very explored, particularly to do these particular milk proteins that have nice barrier and mechanical properties, and to try to pack cheese or breads. So yeah, there's some possibilities to use these natural biopolymers. And because we can find them everywhere, they are abundant, and most of them are also not expensive, and they are biodegradable, which is a convenient feature, particularly in the post-usage of the packaging.
And what food products can you use these materials for?
Yeah, so these natural biopolymers can be used specifically for fruits and vegetables. And here there's some examples of commercial products that we have in the market, and also the effect, how it can improve the extension of, for instance, for cucumbers, apples, carrots, to really to improve or delay the aging or the degradation, deterioration of the food. So here are some examples. And the reason why these natural biopolymers are mostly applied on this type of food products is because they are, particularly polysaccharides, they are mostly hydrophilic, which means that they easily dissolve in water and they don't resist so much to moisture or aqueous environments. And of course, they also come with a complexity because they have different chemistries that gives final different properties. But of course, like all the materials, this can be improved by different ways, like doing coatings or blending with other materials and make the laminates, or even modify the chemistry of the biopolymer by itself. Yeah. And lately, the last category of food packaging is just a curiosity. It's like what seems interesting. There's many startups looking now at this type of possibilities. That is to use these plant leaves or mushrooms or bamboo. And this is not a really new concept. Tribal civilizations have been using this to pack food or to transport food. And the reason why these materials have been considered is because some of them have interesting properties like thermal insulation, they have okay mechanical stability and water resistance, but also they can be also composed. much more faster than, for instance, petroleum-based. So this is also an advantage, of course. And some of them bring some bioactive properties like antimicrobial, which in some cases, particularly if you think about meat or other foods that get contamination from microbial contamination, could be relevant to have a material like this. And here there are some examples of packaging materials made out of these natural materials in food. Yeah.
Very nice. And why do you think we do not see more of these natural materials or biopolymers or these alternative materials out there in the market?
Yeah, that is a very interesting question. And so you mean both the natural biopolymers and also this category of...
Yes.
I would say mostly, if you think about natural biopolymers, is mostly about because they have these low barrier properties. So this is not really convenient in some food applications. They might need to be modified or placed together to make composite materials to improve the properties. And when it comes to these type of materials like leaves or bamboos, there's some issues regarding the scaling up. If you want to produce, we need to imagine. One good example is banana leaves. Banana leaves are very wild, explored on this, and if we want to make a massive production of this, might be challenging and also might be interfere with the ecosystem with the natural ecosystem and affect and disturbing somehow. Besides the fact that there's some properties and some testing that is not known. So basically, these companies come and they made the claims to sound sustainable, but there's not so many testing in terms of material properties and other required to fulfill the requirements for packaging, a good packaging system.
Yeah. We've actually just received a question from Mette regarding this topic about biodegradability. She's asking this about biodegradable. Where do you do this? Is something you can do at home, or do you have to collect it somewhere, or how is this done in practice?
Yeah, it's a good question. So depends on the material you are talking, but if it's biodegradable, you can do it at home, but you need to have the specific agents that will facilitate the biodegradation, like can be enzymes or can be some other type of microorganism. So if you have it, definitely you can do it. But of course, the biodegradation is very specific, particularly if you talk about or think about the enzymes. They just work in optimal conditions. So it's like not you cannot just do it randomly to have it going in the fine way. But of course, sometimes most of these natural materials, they can also suffer some kind of erosion. So in that case, but of course, it's much more slower, the process of biodegradation than if you put in contact with these microorganisms or enzymes.
And what if it's a compostable product? How do you then handle it?
If it's a compostable product, how do you... the same way, you need to have specific conditions to do it. Yes.
And we actually also received a question here from Nikolai. He is asking regarding food safety. What should you be most aware of or pay attention to if you would like to convert from a PET to a RPNT?
Okay, I don't know, maybe Git is more expert on the food safety here. I don't know if you want to...
Do you have an input on this?
I would say it depends on, as you said, the temperature conditions for these different materials could be different. If you talk about PET intended for high temperature application or APT for no high temperature conditions. So I think you should use them for different applications and what they are intended for.
Great, thank you so much. And if you also have a question out there, please fill in the form below the video, and I will receive them right here straight away, and I'll bring them into the discussion. But now we have been talking about some different materials, what are out there, what are the opportunities, what maybe the challenges with the different materials. And now maybe we can talk a bit about the packaging in a sustainability perspective. Maybe you can elaborate a bit on that, Gitte?
I will, surely. Yes. Then, as I said, we'll turn on to talk more about sustainability and what does it mean, sustainability. And I just start to bring attention to the original definition of sustainability, saying meeting the needs of the present generations without compromising the ability of the future generations to meet their needs. And this is, of course, a very broad definition, and we know now from this, and a way to achieve or try to achieve this goal is that we must reduce the climate and environmental impact from human activities and productions to sustain the ecosystem. So what then when we speak, as we do today, of food contact materials? Yes, as Anna said already, we have to look into food packaging in combination with the food, and always look at this as a combined system. And this is because, first of all, we should continue to avoid food waste. And the food has a much higher release of carbon footprint compared to the food packaging material itself. As you see up in the top here, that 80% comes from the food, whereas only 5% of carbon footprint is from the packaging material. And therefore it is still very important, as it has always been already, that the packaging preserve the food as good as it can. So then the first decision to make to choose a packaging that should be more sustainable is still to choose the right kind of packaging that preserve the food mostly. So when we have done that, or you have done that, the industry have done that, the next thing is that you can start to compare different kind of packaging materials. And there we have to look into the full life cycle of plastic packaging and to see what is the environmental impact from this life cycle. The life cycle of plastic is in 4 main steps, starting with sourcing of the feedstock, the production of the plastic, the production of the packaging, and then finally end of packaging. And all these steps use energy and gives emission of greenhouse gases to some extent. But the most important steps are the sourcing of the feedstock and the end of life, as these 2 steps are having the largest impact on climate and environment, and these can also vary most between different kinds of packaging materials. So of course, these can be, the sourcing of feedstock can be from petroleum-based source, or it can be from biomass source. And if we look at 2 materials, one produced from petroleum-based source and one produced from bio-based source, and they have equal properties in protecting the food, then it is generally assessed that the bio-based plastic packaging has reduced climate impact. That is a general assessment based on life cycle assessment studies and reported in the literature we've been through. But it is not so easy, because there are also other things. When the bio-based packaging is produced from bio-based, the type of feedstock can be either from primary crops, that mean crops that are normally used also for food and feed production, or it can be produced from agricultural waste feedstock. And this depends a lot on the climate and environmental impact if one or the other of these kind of feedstocks are used. And to make this evaluation and assessment, you will need to use life cycle assessment to evaluate this. So let's have a look on when we produce crops in the for production of biomass, for production of bioplastic. Yes, you start to have the plants growing here, and when the plants grow, they uptake carbon dioxide from the atmosphere, and you produce a biomass. In this case, it is corn. And then these substances, the organic substances, sugar and starch, is further converted into organic molecules that end up producing the component of the plastic materials. And when plastic is produced in this way, we call that it is produced from renewable materials, which is different from production from oil with non-renewable materials. However, when we use or produce plastic from biomass, the biomass here could also have been used for food and feed production. And thereby the biomass production for packaging compete with the production of food and feed. And we know all that we still need food and feed, and probably this will also increase as global population is increasing. And if we then also intend to increase the biomass production for biopolymers, then we may need to have more land. And to have more land, yes, that will probably mean that we need to have clearing of more forest and plowing of new soil. And when we start plowing of soil, we start a degradation process where we have degradation of the organic matter in the soil. And this will then release carbon dioxide into the atmosphere. So from this production, we have emission of greenhouse gases into the atmosphere. So this make a less benefit than to the biomass or the bioplastic production, because you have to see it as a holistic, as a whole concept. You cannot just see isolated or look isolated on the biomass production itself. You have to see it as in its whole perspective, because it actually increase or can increase also the emission of greenhouse gases. And therefore, we need to include what is called an indirect land use change. This is the land that we need to new land that we need to bring in production. Also, other impacts are seen from production of biomass used for bioplastics. This is different environmental impacts from the feedstock production. Again, when you produce a crop in the field, it will use water, it will use fertilizers, it will use pesticides, and all this together gives different impacts on the environment. And some of these can be eutrophication from the fertilizers, it can be photochemical ozone creation, and it can have negative effect on the biodiversity. So all these things should also be taken into consideration when evaluating the impact from a bio-based plastic material.
And can you maybe give an overview, Gitte, of some of the materials there's when it comes to environmental impact and also food safety?
I will try to. I will just end this slide maybe to say that when the feedstock is produced from waste in agriculture, for instance, it is considered to be burden-free. So that is very positive possibility. So yes, the overview of this I try to give here. You see in the left part of this table, you see the different kind of plastic, petroleum-based plastic, the bio-based plastic produced from primary crops, or the bio-based plastic produced from waste. And then you have in the top here the climate impact or the environmental impact. And you see here that we know that climate impact is large for petrol-based plastics. And it is gradually decreased when we produce it from primary crops, but it has still some impact, and then it is further decreased when it is produced from waste. Regarding the environmental impact, in the second column, you see that we have, when we produce petrol-based plastic, it is produced from the non-renewable resources, so that has this impact. On the other hand, when we use bio-based plastic produced from primary crops, it has these different environmental impacts, such as the land use, the water use, the eutrophication, and the use of pesticides. However, as you see also here, to give this overview, when it is produced from waste, it is considered to be burden-free, and this is an interesting case to discuss more and to investigate more research in. Is it possible to produce a bio-based plastic from waste? And then I put also in the left or in the right column some perspectives of chemical food safety, because as Anna already mentioned, the chemical food safety is urgent when we speak about materials that are in contact with food. We have for petrol-based plastic, we have a positive list where substances are used in the production is on this list. But we may also have NIRs in petrol-based plastic. But when we talk about the natural or the bio-based plastics, both the one produced from primary crops and from the waste, we will also have NIRs, mean non-intentionally added substances. And some of these may be adverse substances, we don't know. But as it is natural material, there might be substances that we should be aware of. And I think that more research is needing and more data is also needing in this. So, of course, some of these materials will also be produced from positive list substances as if it is produced from monomers. So you can see, this was just to try to give an overview, but you can see there are some maybe interesting perspectives in producing of bio-based plastics from waste in relation to its environmental impact. Yes. Then we go to the second part of what we're going to talk about, the other step in the life cycle of plastic. It is the end of life, and here we talk about end of life of post-consumer packaging. So the end of life is an important part, as it also have a large influence on the degree of sustainability of a given packaging. And as you see here, it's a waste hierarchy starting at the top with reuse of materials, and then the impact on environment and climate decrease from going from the top to the bottom. And the reuse mean using the material, the packaging again as it is. For instance, a bottle or a bowl or something that you can use again. This is very attractive in relation to climate and environment if it's possible, but it is challenging because it needs to be collected, it needs to be properly cleaned, there's some transportation. So I think it can be seen as a possibility for some specific areas, but not as a general system for all plastic packaging. This is then the next step, recycling, where we actually recycle the material and produce new packaging materials from the recycled plastic. And then below this we have incineration, which produce energy, but of course also produce carbon dioxide. We have below that the composting, and I will come back to that later in the presentation. And then in the lowest part of the triangle here, or of the waste hierarchy, we have the landfill, and this has the largest impact on climate due to its production of carbon dioxide and methane. So recycling is seen as most relevant way of reusing of resources in packaging materials in EU at so far as we know now. So, and the way of recycling, that the mechanical recycling is the kind of recycle that has most focus. And here you see the different steps in the mechanical recycling, starting in the left side with the packaging waste, and then it has to be sorted, grinded into pieces, washed and cleaned, and then you can produce new packaging materials again. And this could in principle go on for several times depending on the properties of the given materials, if it's able to do that. And you see by doing the mechanical recycling, you can reduce the use of resources simply because you skip this step of sourcing of feedstock, and you skip the step of producing of a plastic material. So in that way it is attractive in reducing the impact on climate and the environment compared to a virgin material. And it is also having a larger impact when you compare it to chemical recycling, as it is less has less processing costs, it uses less energy, and it has less climate impact. So how can we then improve the recycling of a packaging material, and how can we improve mechanical recycling of a packaging material? It needs to start at the design and production of the materials. This is where you select the materials for your packaging or for your food, and it is also where you select that it is actually able to recycle. So mechanical recycling you materialize in the end. And that means you should select a material that has where the plastic are able to preserve the properties, mechanical properties, or that these properties can be reproduced in the recycling process. So you need to have a material where you can produce a recycled material with constant quality specification. And these such quality specifications still need also to be given as standards in for the different materials. Also, another thing important for if you should recycle a material, you will need to use monoplastic packaging materials, maybe with some kind of barrier, but you should avoid the multi-layer plastic because they are not recyclable into a good quality plastic material. And if multi-layer plastics are used with different materials, it should be able, of course, to separate the plastic layer from the other materials. Moreover, again, it is very important to stress that the design should be able to make sure that the recycled material is still chemically safe when it is used in contact with food. And that means, again, you should select wherever possible the most inert plastics without formation of adverse reaction and degradation products, the so-called, again, non-intendedly added substances. And you should avoid printing, inks, adhesives, lacquers, and such thing in and on your plastic materials, because when these are recycled together with the plastic, there is a risk of formation of non-intendedly added substances also from this. Regarding recycling of food contact materials, we have in EU a regulation back from 2008 already. It was given, and the two basic requirements in this regulation is that the recycling should be in a closed loop system with maximum 5% of non-food contact materials of plastic into it, and you should effectively could be able to documentate that there is sufficient cleaning of all potential contaminants in the material.
And if we now look from this sustainability point of view, we've looked at these different materials.
Yeah.
Is there a material that you would especially recommend for food products?
I have this material, the polyester, polyethylene terephthalate, which is already used as recycled material. Mm-hmm. It's difficult to say if it's, I cannot just here say if it's more sustainable material, but it is as recyclable material. Mm-hmm. So this material is found to be very to keep its property when it is recycled, or be able to, or they can be reproduced in a mechanical recycling process. And it is possible to clean this material in the recycling process if it's recycled in a closed loop. And you can have a uniform quality of recycled PET then that can be used again for food contact materials and in contact with food. And this has been evaluated several times by the European Food Safety Authority, EFSA. Mm-hmm. So, and this has in general a very low migration of chemical substances, this kind of plastic. So it has some advantages compared to several other plastics. Yes. for instance, comparing them to polyethylene and polypropylene, which is also used very much, as Anna also mentioned, as food packaging materials. But these are not authorized as mechanical recycled plastic for food contact. And this is simply due to chemical safety issues with these materials. They are producing NIAS, or they are contaminated with NIAS in the recycling process. So the recycled PP and PE can be used for many other applications regarding non-food applications. And last year there was a very nice publication from the Danish Design Guide where a lot of these examples are actually given from the plastic industry. So another question could also be, is a mechanical recycle of bio-based plastics a possibility? And yes, Anna mentioned the bio-based version of PET and PE and PP, and of course these could be recycled as well as the petro-based kinds of these materials, as these are produced just from biomass, but they have the same constituents, and therefore they can be as well recycled together also with the petro-based kind of the same materials. When it's come to other plastics, it depends on their chemical properties. PLA is one kind of polymer, bio-based polymer that technical, from a technical point, is able to recycle. Again, should be used for non-food application, as there's no authorization regarding this to be used with food. And when recycling, when bio-based plastics are recycled, it is important that they are not contaminating other recycling streams. And now we'll talk about these bio-based plastics that are not PET, PP or PE, but the other kinds. It is very important that these are collected and sorted separately from into other collecting and sorting streams. And there is an issue about these bio-based plastics, as the amount are very low still today, only 1-2% of bio-based plastic compared to petro-based plastic, and therefore to make this cost effective, there will be a minimum amount of material, and this is actually not the case, but maybe there can be some possibility in the future for some of them. So try to sum up again in this table on this matrix, and there I just put in the PET, the PEP, and the PP, the bio-based version and the petro-based version, and try just to sum up what is the differences. Again, we have in the top the climate impact, the environmental impact, and if it is mechanically recyclable. And for the petro-based plastics of PET, PE, and PP, we have again the largest impact on climate. If it is produced from primary crops, it is a lower impact on climate and environment, on climate, but we still have impact. And for the bio-based produced from waste, we have a low impact. And also for the environmental part, we have impact on environmental impact on several factors for the bio-based plastics produced from primary crops. But as we also saw before, if we can produce these bio-PET, bio-PP, and bio-PP from agricultural waste, we have the possibility of having no effect on the impact on the environment. And this is again an attractive or an interesting way of more research, or need for more research in this area, because many of the applications today is actually produced from primary crops. But it would be interesting to see more data if waste can be used for the production. And it's regarding the mechanical recyclability, yeah, it's equal for all of them. They can be recycled into food for the PET and non-food packaging for the other materials. So this is good thing about these materials also, their recyclability.
So if we look at this overview, can we then conclude that the bio-based plastic materials, and then especially the one from waste, are more sustainable than the petroleum-based plastic materials?
We can say that there is this potential, I would say it is, but we need more data and more evaluation on this kind to see if it's actually it's possible to produce it from this waste. And if it's possible, of course, still there should be this evaluation by the use of life cycle assessment to compare the different ways of producing and evaluating the materials. But I think it is a potential solution that could decrease the environmental and climate impact from packaging. Yeah, then I will just bring in a little attention also to the end of life of biodegradable plastics. Also for these, it's very important that if they are recycled, they must not contaminate other recycling streams. It's very important that they are separated from the other streams. And if they degrade in the environment, and I mentioned some of these that might degrade in the environment, it is also important that they do not give formation of micro and nanoplastic. And actually, many of these so-called biodegradable materials degrade very slowly in the natural environment, and therefore they are not a solution to plastic waste so far as we have seen today. But many of these need actual industrial composting with specific conditions to biodegrade. And when talking about compostable plastics, which is often seen as a very attractive way of end of life of a plastic packaging, it is interesting to look at the nutrition value of the compost. Most reason to produce a compost is to have nutrition as a kind of nutrition for the soil and plants. But that if a compost will have nutrition value, it depends on its content of the macronutrients, nitrogen and phosphate and potassium. Because if it has this, it can be able to replace fertilizers. And such kind of nutrients can be in some of the natural biopolymers that Anna mentioned. That could, for instance, be algae or other kind of biopolymers based on proteins. They will have some of these kind of nutrients into them. However, many of the materials that we talk about when we talk about bio-based plastics, they actually do not contain any of these nutrients, the nitrogen, the phosphate, and the potassium. As you see here, I've just shown some molecular structure of PLA and then PHA and the starch. And all of these materials they are composed only of carbon, oxygen, and hydrogen. And when such kind of materials are composed, they will degrade into carbon dioxide and water. And this will not bring any nutrition value from this kind of compost. So you can say, my conclusion is, or the conclusion from reading this literature is that composting of bio-based plastics without nutrition value should not be considered as recycling, as it does not bring resources back to the environment.
Okay. Actually, we have received a question from Torben regarding this with composting materials.
Yeah.
So would you find it useful to use compostable materials here in Denmark and in Europe for your food product?
There could be some few cases where it might be useful. I think did we have it some here? I don't think we have it here, but that might be when we have some kind of packaging that is heavily contaminated with food. In such cases, it might give good meaning to compost the material as end of life, because then you have a mixture of the packaging and the food, and you can get the resources from that. But in a broad perspective, it is not that meaningful to do composting of materials, because you simply lose the resources. That if you don't only bring up if you don't only give carbon dioxide and water, it is not a solution to the impact on the environment. And this was also the conclusion, just one study that showed a composition or study, a life cycle assessment on 2 compostable bio-based plastics, the PLA and a thermoplastic starch, TPS. From this study, it was also concluded that mechanical recycling of these kind of plastics is the most optimal end of life in relation regarding environmental impact and climate impact. And this is then followed by direct fuel substitution, and then landfill and industrial composting was evaluated as the lowest, has the highest environmental impact, and then evaluated as the lowest option for sustainable packaging. And yeah, also here we have this, that the composting may be useful when we have contaminated packaging materials, which are contaminated with food. So maybe by the end, we are almost at the end, and we will have these concluding remarks, or try to give at least some concluding remarks. We can say, in general, it is a very complex case, and a holistic approach is needed when aiming at sustainable packaging. And first of all, the optimal protection of the food from the packaging to avoid food waste is the first priority. And then the design for reuse or recycling should be decided already in the start of the design of the packaging, and it has to be done case by case, as it depends on the different materials. Bio-based materials have reduced climate impact compared to petrol-based plastic, but it depends on the kind of feedstock. And more research on the potential of use of waste feedstock for bio-based plastics is needed. And the sum of climate and environmental impacts on the food packaging system in its entire life cycle has to be considered and evaluated by use of life cycle assessment. And then last, biodegradable plastic is not a solution to plastic waste in the nature, and the environmental benefit from composting seems to be of low or absent value. So I think this is the end of this presentation from both of us.
Yeah,
Thank you for your listening.
Thank you so much, Anna and Gitte, for sharing your insights on this topic. And if you have a question for Anna and Gitte, please submit it in the form below. We have already received some questions, and I will just take a few of them. First, we received a question here from Trine, asking if you could imagine a scenario where we don't use packaging on our food products, like you see some places in America, for instance.
Do you want to say some? It's very interesting question. So, but I think still we need to unless you have your own production of foods that you don't need the packaging. I think you always, because you know what you are consuming, you are the producer, you consume it, and you might consume it straight away, so you don't need to transport it, you don't need to preserve it. It's fine, maybe ideally, but otherwise, or either we modify chemically the foods, we need to play a bit with the physical chemical properties of the foods to extend them and to make them more resistant to different types of external agents, or otherwise I see it very difficult the times we live today to live without packaging, but maybe
I'm very much agree with you.
Yes.
Yeah.
Great, and we also have a question here from Maya, who asked if there is a comparative overview of barrier properties in different materials, and you shared that earlier in the presentation, and so I will share that with you as well, Maya, and the rest of you. Do you have any other comments on this?
Well, it's just that each property depends a lot of the material type you are using, so we cannot really create or generalize a material that can suit every single or application. So it's very important to know the chemistry or the functional properties of the material, and of course it changes a lot. There's a table there that has this illustration, but also there's more papers published, and if you need some extra information, maybe you can come to us and we can share with you.
Yeah, and we have a question here from Mette asking if we have this bio-based plastic, should that be sorted for recycling separately away from the petroleum-based plastic, or can that be in the same?
It depends on what kind of bio-based plastic. If it is the same kind as the petrol-based, as
If it's a
mentioned,
PET,
the
for
PET,
instance.
then it can be sorted in the same system as the petrol-based plastic of the same kind.
Great. That is all the time we have for today. So thank you so much, Gitte, and thank you so much, Anna, for sharing your insights. And thank you so much for watching. And if you still have a question, just fill out the form and we will make sure to answer you directly. And if you want to stay updated on news and activities from Food and Biocluster Denmark, you can sign up to our newsletter on our website. Thank you all for watching and have a nice day.
Tak fordi du fulgte med i denne digitale masterclass fra Innovationsnetværket for Fødevarer. Du kan altid finde masterclassen på vores hjemmeside. På gensyn og have en dejlig dag.